All right, so I had some people asking for another example of a trig sub integral. And so we'll take our integral. I'm going to double check my list. Get the integral of x squared minus 1 to the 3 halves over x dx. And so I'm going to build my triangle here, and I like to call this one theta. When I look at the top of the integral, I see x squared minus 1, and so that means I know that x squared is equal to c squared. And I'm going to call this side 1, making this piece here x squared minus 1, the square root of x squared minus 1. So it's just c squared minus b squared. And then I can start writing some trig functions in terms of theta. So, for example, cosine of theta is 1 over x, because it's adjacent over hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. If I flip over cosine, I get secant. So secant of theta is x over 1. And that's really nice to have an expression for x, because then you can take its derivative. And the derivative of secant is secant theta tan theta d theta, and that's going to equal dx. So now let's do our substitution. Tangent is equal to the square root of x squared plus 1, and here I see the square root of x squared minus 1 to the third power. So the numerator can be replaced with tangent to the third power of theta. The denominator can be replaced with secant, or I can recognize that cosine is 1 over x. So I can multiply this by cosine of theta to take care of the 1 over x. The last thing is that dx is equal to secant theta tan theta d theta. Okay. I personally like to then start seeing what cancels out by thinking about them in terms of your regular sines and cosines. I'm going to gather together these tangents to make tangent to the fourth. So I have tangent to the fourth. Tangent is sine over cosine. So I have sine to the fourth over cosine to the fourth. Here I just have regular cosine. And secant is 1 over cosine. So I can do that. And then I have d theta on the end there. So sine to the fourth over cosine to the fourth. Okay. What I'm going to do next is write out the tangent. So I really just have to do the integral of tangent to the fourth theta d theta. Okay, so when I have sine over cosine, I think I'm going to keep it in terms of sine and cosine. I'm changing my mind as I'm going through this video. When I have sine to the fourth, I can rewrite that as, because sine squared plus cosine squared equals 1, so I could say that that's equal to, this is sine squared to the second power, and so I can say that it's 1 minus cosine squared theta to the second power over cosine to the fourth theta. Then, let's see, I can't do a u sub, is not really going to help. Let's expand that out and see what happens. So we get 1 minus 2 cosine squared theta plus cosine to the fourth theta over cosine to the fourth theta d theta. And so Yeah, it's not going to work, is it? So secant to the fourth theta minus 2 secant squared theta plus 1. I think there's a way we can make this work, because when I'm looking at this now, I know the antiderivative of 1. I know the antiderivative of secant squared, because tangent's derivative is secant squared. So the only thing I'm concerned about is secant to the fourth theta. Let's see if I can figure out how to deal with secant to the fourth theta. I don't know if this is going to work. Let's try it. So I know that sine squared plus cosine squared is equal to 1. But what I care about is secant. And so I'm going to divide by cosine, because secant is 1 divided by cosine. So I'm going to divide everything by cosine squared. And that gives me tan squared theta plus 1 is equal to secant squared theta. So what that means is, if I have secant to the fourth theta, I can make that secant squared theta times tan squared theta plus 1. And this is great, because then if I take a u substitution for tan of theta, then du is equal to secant squared theta d theta. So it's going to cancel out that piece there. So I'm going to do that u substitution. I'm coming back down here. That means that I have the antiderivative of u squared plus 1 du minus 2 tan theta, because that's the antiderivative of secant squared, plus theta. And then almost done. I have to get everything back in terms of x, and I have to do one last antiderivative. So we have 1 cubed, 1/3 u cubed plus u minus 2 tan theta plus theta. Let's see, u is equal to tan theta, and tan theta is equal to square root of x squared minus 1. So here is our final answer in terms of x. We have square root of x squared minus 1 to the third power, because I had u cubed. So there's that 3/2 power. Then I have u. And then I have minus 2 tan theta. So minus 2 square root of x squared minus 1. And then plus theta, which is going to be I can do arc cosine of 1 over x. And then plus c. Unless I made a mistake throughout there, that antiderivative should work out. So this was a little bit of a trickier trig substitution example, where we had to do a little bit more work up here to express it in terms of what we know how to do. So whenever you have even powers of your trig functions, you want to think about using your Pythagorean identity here. Sine squared plus cosine squared equals 1. So please comment if I made a mistake or if there are any questions, and I'll help out.